just finished that one. So let's try one more. This graph, they're calling it f of x. That's the name of this function. You can see that right here. It says y equals f of x. So I'm going to go ahead and label my x and y axis. I'm going to label this as x. I'm going to label this as f of x. The same thing as y, right? It's my vertical axis. Now they're not labeled. It's not, it's counting. Let's just count by ones. So I'm going to go ahead and label these values. And this graph, do you see it actually comes to the left of the y-axis? Let's go ahead and label how far left that goes. What do you think that would be? That what x value? I think that's like -1, right? It's about the size of those squares over there. So we'll estimate that that's at -1. Okay, and then of course this is 0. Our origin is 0, 0. Okay, I'm going to color code the same way I did on the last one, with my vertical axis being green, my horizontal axis being yellow. Remember the x's, the horizontals, the inputs. So this first A and B are giving us input values. They're saying f of 4 is what? F of 6 is what? So given the input, find the output. So I'm going to go to my input, my x, and find 4. So that's right here. Okay, and here is my graph. When x is 4 on my graph, what is the y value here? 0. You're on the x-axis. That indicates that there is a coordinate, an ordered pair at 4, 0 on that graph. That's a special key feature. That's a special point. What is it? It's the x-intercept. It didn't ask that, but I'm just asking as a refresher. That is your x-intercept. We talked about key features for like the past week and a half. Okay, if it's, well, that's where it touches the x-axis. All right, then what about for B? We want to find our input of 6, that is here. Okay, so my graph is here. At what y value? There it is, 4. So that's telling me that there's a point at 6, 4. Okay, that's that point that I distinguished right there, or that I accentuated right there. All right, now C goes backward. Says, okay, well, what if f of x equals 2? So instead of telling us x is 2, they're telling us the output is 2. So we go to our vertical axis and find 2. That's our starting point. We're going to find where our graph is, and there's 2 places, here and here. So 2 locations when y is 2, or when your output is 2. What are those x values? Yeah, 2 and 5. Okay, I didn't highlight that. Let me highlight. So that was f of x equals 2. All right, what about f of x equals 1? So we are going on the y-axis, or the f of x axis, to 1. And I'm going to find my graph, and I've got 1, 2, 3 places where my graph exists when the y value is 1. Okay, what x values are those? What is this x value? Yeah, that's about halfway to 1, so I'd say 0.5. Okay, this one, 3, so we've got 0.5, we've got 3, and then this last one, yeah, I'd estimate about 4.5. So I'm just going to list those out. I'm going to say at 0.5, or you could write the fraction if you wanted, at 3, and at 4.5. Now, E is asking a different question. It is not asking for the specific X values. It is simply asking for how many X values make this statement true. So how many different places is this true? F of X equals 0.5. So it's the same process. We just don't have to give the specific answers. We just have to say how many there are. Okay, so I'm going to draw a line at X equals 1/2. That would be right here. So how many times does my graph touch that line where Y is 0.5? Yeah, I can see here on the just to the left of the y-intercept. So that's 1. Then here again, that's 2. Then here again, that's 3. So there are 3 places where that happens. 3 places where that's a true statement. I don't have to say what they are, just that there are 3 of them. Okay, F asks for the X value, where or what for what X values is F of X greater than 2? So this one is a different type of question. F of X greater than 2. F of X is our function. That's the vertical axis, right? Or the y-axis. So we're talking up and down. So if you're greater than 2 going up and down, that means above 2, doesn't it? Okay, so where is our function? Where is our graph greater than 2? Where is it above 2? So I'm going to make a dashed line here at 2 just to help us get a visual. And we're looking for where our graph is above that dashed line. Okay, see the top of the graph there. So I'm going to highlight. Here, once we get my graph, nowhere here is it above that line, is it? It touches the line here, but is that greater than 2? At that point, there's a coordinate at 2, 2. Is that above 2 or is it equal to 2? That's equal to 2. Okay, so that is not gonna, that's not a solution here. It is not above 2 there. So I keep going. Here again, it's equal to 2 when X is 5, but it's not above 2. It goes above 2 here. This section of the graph. Do y'all agree? So they're asking for X values, for what X values is that piece of the graph. So we said that that started at the 5 and that ends at the 8. So from 5 to 8 is where this graph is above 2. Does it include the 5? Did we say? No, it's equal to 2 when X is 5. It's not great. There's no or equal here. So we do not include the 5. Do we include the 8? Is it above the 2 at 8? Yes. So not including 5, yes, including 8. So as an interval, I would say from 5 to 8, not including the 5, so a parenthesis, including the 8, so a bracket. Okay, now G takes us back to the basics. What's the domain and range of the graph? So this graph goes all the way from left to right here. So what is that furthest left X value? We said -1, and the furthest right? 8. So the domain is left to right, it's X values, so it's -1 to 8, and it includes both. It's inclusive of the -1 and the 8, because the graph exists at the beginning and end of those line segments. Okay, what about low to high? What's the lowest this graph goes? And the highest? 8. So the range is low to high, it's 0 to 8. Also inclusive, brackets on both. We feel okay about using graphs to evaluate with function notation? Okay, and on the front, it was using the graphs, or not using the graphs, using the equations to evaluate function notation. All right, good, because we need to really understand function notation to do inverse functions, which is next. So I'm gonna stop this video here and I'll start a new video for inverse, the next page of the notes.